Pythagoras in 3D. The Pythagorean theorem states that in a right-angled triangle, the square of the length of the hypotenuse, the side which is opposite the right angle, is equal to the sum of the squares of the other two sides. In 3D, this theorem can be extended to relate the lengths of the three sides of a right-angled solid shape called a right rectangular prism. A right rectangular prism is a solid shape that has 6 faces, all of which are rectangles. It is called right because the angles between adjacent faces are all right angles, and it is called rectangular because all of its faces are rectangles. The Pythagorean theorem can be applied to the right rectangular prism as follows. If A, B and C are the lengths of the three edges of the right rectangular prism, where C is the length of the hypotenuse of a right-angled triangle that is formed by two of the edges, then C square equals A square plus B square. This equation can be used to calculate the length of any edge of a right rectangular prism if the lengths of the other two edges are known. It can also be used to check if a given solid shape is a right rectangular prism or not. Worked example. The diagram shows a cuboid PQRSTUVW. PV is 17.2 cm. The angle between the line PV and the base TUVW of the cuboid is 43 degrees. Calculate PT. The lines PV, PT and angle PVT forms a right triangle. To make it clear, let's draw the lines onto the diagram. Like this. This angle is 43 degrees, this PV is 17.2 cm, and now this PVT is a right angled triangle. The side opposite the angle is needed and hypotenuse is given, so use sin theta is equal to opposite over hypotenuse. Sin 43 will be PT over 17.2. So now solve for PT. PT equals 17.2 times sin 43 degrees. So PT equals 11.73037179 and so on. Rounding to one decimal place, it is 11.7. Examination tips. Add lines or triangles etc. to any given diagram to help you see the problem and draw any 2D triangles separately, as a 3D diagram can get hard to follow. Test yourself. Question number 1. The diagram shows a triangular prism which is not to scale. AF is 10 cm, AB is 24 cm, and BC is 8 cm. Angle FAB is equal to angle ADC is equal to angle BCD, which is equal to 90 degrees. Work out the size of the angle between the line BE and the plane ABCD. Give your answer correct to one decimal place. It's a 3-mark question. Question number 2. The diagram shows cuboid ABCDEFGH. For this cuboid, the length of AB ratio the length of BC ratio the length of CF is equal to 4:2:3. Calculate the size of the angle between AF and the plane ABCD. Give your answer correct to one decimal place. It's a 3-mark question. Question number 3. The diagram shows a pyramid with a square base ABCD drawn here. The diagonal AC and BD intersect at M. The vertex V is vertically above M. AB is equal to 11 cm and AV is equal to 18.6 cm. Calculate the angle that AV makes with the base. It's a 4-mark question. Question number 4. The diagram shows a cuboid with dimensions 5.5 cm, 8 cm and 16.2 cm, which is not to scale. Calculate the angle between the line AB and the horizontal base of the cuboid. It's a 4-mark question. Question number 5. The diagram shows the prism ABCDEF with cross-section triangle ABC, which is here, not to scale. Angle BEC is 40 degrees and angle ACB is obtuse. AC is equal to 6 cm and CE is equal to 13 cm. The area of triangle ABC is 22 cm square. Calculate the length of AB. Give your answer correct to 1 decimal place. It's a 6-mark question.